Welcome to this demonstration of using bolt connectors in the Autodesk NASTRAN in-CAD solver embedded in Inventor. During this video, we're going to run an analysis to find out whether the bolts will outlast the gear or the hub under extreme loading conditions. Taking a close look at the design, we have several bolts, nuts, and washers being used to fasten the components in the assembly. There are a couple approaches that can be taken to set this analysis up. First, we can analyze the bolts as they are and gain some knowledge of the stresses on each of them. The second approach is the use of connectors. Connectors act as one-beam elements, which solve extremely fast, and they also provide additional information for the shear and axial force. Now that we know the setup we're going to use, we can hide the other parts in the assembly, including the fasteners. Autodesk NASTRAN is fully embedded in Inventor. You will see the NASTRAN tab in the ribbon, as well as the FEA browser for making it easy to set up the analysis. Let's create a new study. There are several solver options for efficiency. We'll add the option to calculate the forces for the bolt connectors. The material for each part can be selected from a standard library or imported directly from the CAD model. We're only going to mesh the hub and the gear, so we'll select those two parts and confirm the material we want to use. Next, we'll apply some boundary conditions to virtually set up the model. For our purposes, we can fix the center of the hub, and we'll apply a load to a portion of the gear. There are several ways to apply the load. Use options such as force, pressure, moment, gravity, centrifugal force, and prescribed displacement. There are also loading conditions for thermal studies such as heat power or prescribed temperatures. These loads can also be described with variable distribution for hydrostatic scenarios or bearing loads. Now it's time to fasten the two parts using bolt connectors. There are several types of connectors that are available, such as rods, cables, springs, rigid, as well as bolts, which we're using here. Notice there are settings for using threaded bolts or nuts. The bolt diameter is automatically set to the diameter of the hole, or edit the size if necessary. The material can also be selected, as well as the option to apply preload. Like many of the other dialogues in Autodesk NASTRAN, there is an option to keep the applied information available for adding additional connectors using the same settings. Now we can go ahead and mesh the model and run the solver. Once again, we have greatly reduced the time it takes to do both by using the connectors for the fasteners. There is no need to set up and run all the contact conditions it would take to solve them as solid elements. We can not only get the job done faster, this also provides more time to make changes if necessary and drive innovation. Let's take a look at the results. We'll begin with a stress plot for the gear and the hub to find out where there are areas of concern and determine the factor of safety. We'll change the maximum value in the legend to 250 megapascals. We can see there are a couple locations with high stress concentrations. There is an option to dynamically query the elements or nodes at your mouse cursor. We're looking at a factor of safety below a value of 2 for the hub based on the yield strength of the material. Now let's talk about the fasteners. By animating the plot, we can visually see there is shear and tension on the bolts. You can see in the pull down, there are several options available for beam information. Let's begin with tension. The highest axial force we're seeing is only 111 pounds. Now let's take a look at shear. Each beam element contains the force at both ends. We'll use the query option to probe the two values to come up with the shear force on the bolt. We can see there is over 1,100 pounds on one end. On the other end, we see just over 1,000 pounds in the other direction. With a simple calculation, we can determine the factor of safety for tension and shear for the fastener. With a factor of safety of 5 on the worst-case bolt, we can safely say the fasteners will outlast the components they are being used to hold together. Autodesk NASTRAN in Inventor not only provides the results we need to validate the design, as you have seen here, it also provides the tools to get the job done faster using connectors.